Our project is making solar energy economical, the power of the sun, by Thomas, Sean, and Hao. Our NAE Grand Challenge is about making solar energy more economical. This is a modern-day challenge as the world is slowly pushing away from the use of fossil fuels and leaning towards cleaner and renewable energy alternatives, such as solar energy. Solar energy is collected by solar panels that convert the sun's rays into electricity by exciting electrons in cells using the photons of light from the sun. This technology has been around for decades, but its uses vary as the costs of solar power are anything but cheap. Our project is based on the implementation of solar panels into roads and parking lots in order to power our future. We developed a program that uses data from countries all around the world and sorts and compares them in a way that will be useful in the logistical scale of projects for engineers around the world. Our code also calculates the amount of solar panels that are required based on household power consumption and efficiency of solar panels used, including the area that will be occupied by said panels. This is important information for a project that will push the very infrastructure of a country into the future.
My name is Thomas, and I'll be going through our project code with y'all. To start off, we have our house clearing commands, and we have our references that we import into our program. Here we had some unnecessary columns, so we ended up modifying our matrix a little bit. And here we have our first while loop, and this ties us into being able to repeat our program if you so desire. Here's our repeat, and here's the end of our while loop. And so we'll be able to repeat our program as many times as you want. And here's our first main menu. It has 4 selections, and so these are broken up into each topic that we will talk about today. Anywhere that we have a menu, we will require you to select one of our options. So we will have a while loop to force you to select one of our options. And so moving on to our first task. And so here we're able to select project year, and then from the year we have our string topics, and then that's all in one row, and then underneath that row we have all of our values that you can observe for that year. And so once we have that, you can output that statement with each topic along with its value that is stored, and then you save the variable. And then moving on, we have our subplot of our graphs from one of the references above, and it will give you a nice observation on that topics. Moving on to menu 2, you have all the specific topics that you can observe, and then again I can close out the menu, and then many conditional statements. You have your variable with the data that's stored, and then we have our output commands to show you what the topic is and its values. So we have 16 of these, and we go until we hit 16. And so it's all the same, it's just different topics. Again, we have our plot again, just to show you again the graphs that we have. Moving on to menu 3, we have our continent. You can select the continent, and then you select the country. And so here's all of our data for our country names and our country data. Again, we have conditional statements, so whichever continent you choose, you go into that region and you can select your country in that specific conditional statement. And then we have our country data and our country name that you can store, and then you have an output statement that tells you what country that you have selected, and you do that for each continent here. And then lastly, you can save the variable. And moving on, you can see all the different power productions for each country. Some of them may have multiples, so it will display each one for you and in a descending order. And then here it will give us a graph on comparing each power production comparing to each other. And then you can take the average if you so choose with this menu statement. If you do, you will be given the output for the average, and then you'll be able to select input your own input for some of the topics, and then you can be able to calculate total wattage, the number of panels you want, and the total land used, and then it will display that in this fprintf statement, and then you will be able to save those variables as well. Moving on to our last task, you can input as many countries to select as you want, and so here we will require you to just put in 2 or more. And so again, we have our continents, and then we have our countries, names, and data, and then we have our for loop from 1 to whatever number of countries that you would like to observe. Again, we have a menu for a continent, and then once you select your continent, you have if statements, you have conditional statements, and then you have a for loop inside each conditional statement that will store the country data, and then you will also store the continent name and the country name, and then you do that for each continent. And then lastly, for our fprintf statement, it will tell us the number of countries that we've selected, and it will tell us which countries that we did, and then we will display all the countries and the continents and its data. And then lastly, we'll save the countries, and then you'll be asked to repeat if you would like.
The main usage of our code is to assist and support an engineer in the logistical application in placing solar panels around the world. Our code simplifies data and has the ability to sort and compare the information of different aspects of solar power in different countries around the world. While we would like to talk about how our project is amazing and awesome, we must get into the nitty-gritty. Not everything is perfect, and as such there are limitations on the code and the very idea itself. The sheer scale of such a project that installs solar panels into roads would be absolutely massive, and as such not easily accomplished. Therefore, our code has a very niche and specific application. The code also requires current, up-to-date data from countries all around the world. This can be an issue, as not every country keeps the same quality data and the same amount of records.
Okay, so my name is Hao Huynh. So today I will be talking about the specific topic and single country data of this program, and let's see how it works. So let's choose the single country data first, and it tells the user to choose a continent. So I will choose, for example, North America, and I will choose United States, and in here is the power production of United States. It was uh, arranged in descending order, and here's the graph of the power production. And there are 10 power production here in United States. So we will take the average, and here's the average. And then um, let's type in the size of the solar panel and the 2-in-1 vector. So as we can see, if we type in the negative value, it will turn back and tell the user to enter the positive value. So I will type in 5.6, and I will type the wattage, which is 320, and enter the average wattage. I will type in 0.1, and I will type in 10 hour sunlight exposed. So right here, it tells the user that the total land required to power this 9,326 solar panel for United States, for this much people, so many people. Uh, Here is the total land which is 279,000 square feet. So let me choose another data set. So I will type in, choose another ones in the country data. So I will choose like, for example, Asia. And then I will choose like, for example, like Japan. And here's the graph of Japan with the power production. And then take the average. Here's the average. So I will type in another size of solar panels. I will choose like 2, 3. And the wattage, which is like 250. And then 0.2 or 0.3. And then the time of sunlight exposure will be 8. And then we will calculate the total land of Japan. So let's choose the specific topic. So this specific topic, it will help the user to find out and investigate the money and the tax. Well, something stuff that related to finance. So I will choose like, for example, operating expenses. And then here's the number, here's the data for 30 years. And here is the graph of cumulative cash flow and the revenue and tax benefit expenses. So let's choose another one, for example, specific topic, and then choose cumulative cash flow. And here's the cash flow for 30 years. Here's the cash flow for 30 years. Cumulative cash flow for 30 years with the graph of it. So that's it for the video. Thank you for watching.